We're going to see today demonstration on how we can bring into Nastran 4D or SimWise 4D a three-dimensional model drawn in with a three-dimensional program. So the idea is to be able to draw a system or parts of a system and assemble them into a working system, generating them into a solid modeling program like SolidWorks, Solid Edge, CATIA, or whatever, and then we'll bring into the SimWise 4D to be able to do analysis. So let's see how that goes. In here we have SimWise 4D running on the left hand side, and we have the tutorial on the right hand side. So we're going to go step by step. In this case, we are going to open a file called piston begin, which contains this piston assembly here. We're going to go to file open. See where that leads us to. That is going to, we need to find out where the program is installed. That's um, where that is. So we're going to go over here. No, it's not, it's this one. So you'll see here down, we'll go take a look here, SimWise 4D. And then it has evaluation kit, which is the one that we're doing right now. So, yeah. So and then we're gonna piston begin here. And then you say fine. So this is what we have right now. Well, so let's see what came in, and also we'll compare to what the tutorial is telling us. So if you go here and you run it, this is the result. Not very good. Things don't work like this. And in fact, let's examine the situation. What we see here. We see that the crank, for example, rotates widely, randomly, sometimes clockwise, counterclockwise. See right there. And as time goes on, the situation gets more complex. It's turning one way, and also the piston and the connecting rod have problems. It's very obvious to see in there that the connecting rod and the piston do not see that each other is a different body, because there's no collision. It goes through the element. And the crank is just basically going with, with the crankshaft is going basically with due to the reactions that each one of these um, turns have, as potential energy gets transformed into kinetic energy of rotation. So not very good, well, not very good organized. So let's go set it back up, and then we're gonna go to the tutorial and see what it says. This says press I to look at the isometric view of the assembly and run to observe for several seconds. This is what we have done. So, okay, explain, we're gonna bring in from another program, and in here you say create the contact between the piston and the head and the connecting rod. Select the piston. While holding down the control key, select the connecting rod, and then check on the object menu, say collide. So we have in here, and then we have hitting the control key, and then go to the word object and say collide. Okay, if you click on run, you will notice a big difference here. So let's just go over here and see what happens. So now you see the piston and the connecting rod act very differently than before. The connecting rod does not go through the piston. Mhm. There we go. There we go. So that is the connecting rod and the piston now collide with each other. But again, the motion is random because depending on the reaction forces due to the initial conditions and the initial kinetic energy release as the crank and the piston go down, due to those reactions, the crankshaft is rotating also widely, sometimes clockwise, sometimes counterclockwise. Um, the reason it hasn't stopped is because during the simulation of these three-dimensional objects, um, no friction has been specified. So this thing could go on forever and ever because of the principle of conservation of energy, principle of conservation of momentum. So we need to reset things and then move on and possibly put put a motor to this so to make it work like a real engine works. So that's the next step. At this point, you can see the crankshaft rotates freely because it's constrained by the revolute joint. But to drive the piston, we will convert the revolute joint to a revolute motor. So this joint connects the crankshaft to the fixed part called the anchor 1. See this picture below. So you see in the you have it on the see right here, anchor 1. Yeah, that's this little body here. And of course you have we need to put the motor in here, but so that we can make it rotate. And so first we need to do we need to fix that so it's not a problem. Say click on the anchor and the revolute will appear in the connections window, and then it's identified by this green circular symbol. See, this is crank 1 constraint. So right click on the revolute joint in the connections window and select properties. There's the connection window. So we go over here and we select properties. So choose the constraint tab, scroll down to the revolute motor and then select it. So the connections window is here. That's the constraint here. The constraints that we have are, where's our little symbol here? Right here, see? You go to the revolute motor right there, and then select it, choose the appearance tab, and rename the constraint crank 1 if necessary. So we go